This is feedback for component 3 mock, and this is paper A3. We're on question 3, and you immediately recognise some bits of the heart and think back to the huge box of laminated questions that all looked very similar to this. The diagram shows the left side of the heart. So left side of the heart and 3 stages of the cardiac cycle, and we've got some valves here. Here's our three stages, and where do we are? A and B, okay, right. Atrium, ventricle. Okay, so this is the pulmonary vein coming in, and that's the aorta coming out. Atrial systole is the atria contracting. Ventricular systole is the ventricles contracting. Ventricular diastole is ventricles relaxing, but also the atria kind of in a fairly relaxed state. Give the name of the valves at X. So X is the valve, so ventricle going out into the aorta. So we've given you the name semilunar valve. It does have another name, the aortic valve. So either of those will be fine. So semilunar or aortic. And Y, again, various names we could use here. It's an example of the AV nodes, the atrioventricular nodes, but it says give it its name, so it's the bicuspid valve. We could also say mitral valve's got another name there as well. But these are the names that our textbooks and notes use, so you stay safe with those. Complete each diagram by drawing the valve at position X and Y, showing whether they're open or closed. Okay. Well, the clue here is that atrial systole, so atria are contracting. So atria contracting. That's going to force blood out of the atria. Blood can't go back into the vein because of valves further back there, and so it's going to be forced through here. This valve opens this way into the ventricle, and so we're clearly showing this valve to be open, and our other valve, our semilunar valve, well, here the pressure currently in the ventricle is very low, whereas the pressure in the aorta is generally very high. So blood is trying to follow its pressure gradient back into the ventricle, but these valves open towards the aorta. So these valves kind of open outwards. But when the pressure of blood is coming the other way, these are going to be closed. So we've got the bicuspid valve open and the semilunar valve closed. On this next diagram, we have got ventricular systole. So this is the ventricles contracting. This is forcing blood up and hopefully out of the aorta, and this valve here would then be forced open like that. That's the way that valve opens. And again, blood would try and follow this path back into the atrium, but this valve is forced closed. It can't go all the way through because of tendons in what we'll talk about in a moment. And then we've got ventricular diastole, so ventricles are now relaxing, and so blood is at a huge pressure in the aorta and would like to follow its pressure gradient back in, but this is now going to close. But as the heart expands, there's a negative pressure, so drawing blood in through the veins and atrium. Even though the atria aren't actually contracting yet, this kind of slight sucking effect and some pressure from the veins will open your bicuspid valve. So we're clearly showing closed valves and open valves. Valves Y are attached to the heart by tendons. What is the function of these tendons? And 2 marks. Well, one's okay, the other mark might be a little bit more tricky. So, for example, if I wouldn't put this on your diagram as it might prevent you from getting these marks if you can't see whether they're open or closed or not. But you can imagine some tendons like that. And the main reason that you should be giving is that to prevent these being forced the wrong way. So these could close, but the tendons don't allow them to go all the way through like saloon doors. Else there'd be no point in having the valves there at all. So to prevent the valves inverting or going the wrong way. So to prevent the valves from inverting or being forced the wrong way. And also they keep the tension on the valves. We don't really tend to focus on that, but they maybe stop them flapping around. You can sort of imagine that sort of. So to keep the tension or kind of keep them pulled so they're flat, so to keep the tension on the valves. A little more tricky to come up with the second one, but certainly you should come up with the first one there. During fetal development, there's an opening in the septum. Right, where's the septum? So the septum is this area here, between the right and the left atria. So it's on a two-dimensional diagram. Like it's quite difficult to draw, but you imagine there's a connection between that atrium and the other atrium. This normally closes after birth, but in some cases it does not, and it's known as wholeness in the heart. Suggests the effects of this non-closure on the circulation system and the tissues. So 2 things to go out there. So they're saying the atria are connected together. Well, we know this is the left side and it's receiving blood from the lungs. Whereas on the right hand side, that's receiving blood from the body. And these are 2 different types of blood that are coming back in. we're getting nice, lovely oxygenated blood from the lungs, and the body that's sending back spent blood, with low oxygen in. And what could happen if these are getting mixed up? Well, we're going to send the wrong type of blood to the wrong place. What is the point of sending blood that's already got oxygen in back to the lungs to get more oxygen? It's pointless, and worse than that, you might send blood without any oxygen, so deoxygenated blood, to the body. Imagine sending that to the brain or the muscles, and that's not going to be good. So those are the effects. So we're going to get mixing of of oxygenated and deoxygenated blood. And two possibilities there. We could say, problem sending deoxygenated blood to body tissues. They need to respire, which need oxygen. And the other way around, we could say, less of a problem really, sending oxygenated blood to the lungs. It's just pointless, rather than it being a major problem. And we could also here possibly talk about pressures. You need a large pressure going to the body and a lesser pressure going to the lungs. You could talk about, well, the pressure won't be enough to send it to the body, or too much pressure to the lungs, that sort of thing. But I've gone for the most obvious, easy answer there to complete those 9 marks.